Thank you, Johnny. Today, I'll demonstrate the MKM Labs Physical Risk Program, a flood modeling system that measures and models flood risk based on the CDM foundations. Okay, looking at the code structure, our flood platform creates three core CDM types. This is property, mortgage, and flood gauge. It also generates flood events from gauge readings into time series. The portfolio section creates sample data, while our models section, up here, propagates floods across terrain, calculates property damage using OS climate vulnerability curves, and runs mortgage pricing models measuring PDs and LGD upticks. We've also built interactive tools to showcase today. So I'm running our portfolio builder, which creates CDMs and generates realistic collections of properties with mortgages, floodgates, and storm surges. This model water flow leading to gauge time series that exceed severe warning thresholds. We're also launching our portfolio flood analytics model. So these JSON files contain our detailed CDMs. This complexity is intentional, as we've unified requirements from mortgage teams, insurance providers, and local government into one comprehensive structure. All gauge data follows UK government standards. So let's kick off the visualization tools. So this is a summary report of that flood analysis, showing the typical distributions that you would put in a disclosure type report. The flood risk map is something we've just developed a few days ago, and the idea is that we can go down to individual properties to review their flood potential. So we have here a high risk level, 1.3 meters, is enough to create considerable damage. If we transfer to the interactive visualization, which is the main piece of kit that we have, we can see a red mist, which is the storm progression, starts in Bristol and ends in Margate. And as you can see, we have a portfolio of properties in and around London. So let me dive in a little bit. You can see we've got all our properties with their basic information. And if we right click, we can generate our own report. And the report is long and considerable based on the depth of information that is available within the CDM for property, mortgage, etc. We can also do the same with gauges, give us a bit more information. This one is fully operational. And we can pick out a gauge that is not operational. And we can say it's temporarily offline. So again, this type of information is critical for any legally enforceability of currently parametric insurance. This entire analysis from data generation to detailed reporting was completed in seconds, and it's largely thanks to CDM adoption. And the solution design is now quite standard, i.e. the use of time series. Our next phase connects the real flood events, translating them into accurate gauge readings through scenario generation. We're leveraging parametric insurance capabilities from Oasis, which is the equivalent of Finos for insurance, to create results distributions with tail sets just below the biblical events typical covered by catastrophe insurance. These developments enable capital markets to develop flood risk transfer mechanisms, which we call physical risk swaps. We're partnering also with flood modeling experts to enhance terrain expertise, measuring the basis risk between gauge level defined floods and portfolio asset impacts. This, we believe, represents the future of physical risk in capital markets. And on that point, back to you, Johnny.